Hello everybody, welcome back. Today we're going to look at a third form of the equation of a linear relation, and this is the general form of the equation for a linear relation. So we're going to relate the graph of a linear function to its equation in general form. So the graph is described by the equation 2x minus 3y is equal to 12. Okay, this is actually called standard form. All right, and it's very easy to find the x and y intercept in this form, which we're going to see a little later on. Okay, the coefficients in the constant terms are integers. X and y terms are on the left-hand side of the equation, and the constant terms on the right. Okay, this is for standard form. Now, once you set it equal to 0, now this is called general form. So I subtracted 12 from both sides. What you see here, 2x minus 3y minus 12 equal to 0. This is called the general form. All right. So two new forms, very similar. Standard form. Ax plus by equal to c, and if we take the c and move it to the left-hand side of the equation, this is general form. Okay, so a general form, ax plus by plus c is equal to 0, is the general form of the equation of a line where a is a whole number. Okay, so a is going to be either 0 or usually 1, 2, 3, 4. If it's negative, what we'll do is we'll divide through by the negative. Okay, and b and c are integers. All right, so let's take a look, and we're going to write each of these equations in general form. So we're going to do a little rearranging. So this is slope intercept form, and we're going to change it into the general form. So the first thing you want to do is rewrite your equation. Now obviously we have this 3 that's in the denominator, so what we want to do is we want to get rid of that 3. So what you're going to do is you're going to multiply each term by 3. So we have 3 terms here. We have the y term, we have the x term, and we have the constant term. So what we want to do is we want to multiply everything by 3. Okay? So that's our goal here, to multiply every single term by 3. So I'll show that with the brackets. Okay? So we should multiply each term by 3. Okay? So that becomes, so now we're going to fix that up. And now 3 times y is obviously 3y. 3 times negative 2, that takes the 3 in the denominator, divides with the 3 in the numerator to give you 1, and that's why we did that, because we wanted to get rid of that term. So when we do that, that 3 is gone, and that 3 is gone, as you see there. So the 3 divides with the 3, and it's gone like I mentioned before. And then 4 times 3 is 12. And we're putting in this in general form, so we want to set this equal to 0. So normally, I like to have everything on the left-hand side. So what I'm going to do is I'm going to add the 2x to both sides. So I'll show that here, the next line. So we'll add 2x to both sides. Add 2x. And subtract 12. Right? So we want to get rid of this. So if we add 2x here, and subtract 12, keep it balanced. That's gone. And that's gone. Giving you 0. That's why we did it, right? 0 principal. And then we end up with we don't need the plus at the beginning. We do want this number in front of the x has to be, remember, a whole number. It can't be negative, right? It can't be 0 if it's eliminated. Then the whole term is eliminated. And plus 3y minus that, and then obviously all this gave us 0. And we're finished. And there is our equation in general form. All right. Next equation is in slope point form that we learned yesterday. So we're going to do the same thing here. So I'm going to copy this, and then I'm going to paste it, and then we're going to work with this equation. So again, we want to get rid of that 5, obviously. So Now, because all of these terms are in brackets, all you need to do is multiply this whole thing, because this whole thing would be considered one term. I know there's two terms in there being multiplied, but we only need to multiply this by 5. And what you do to one side, you do to the other. Now, multiplying this side by 5, you don't just multiply the y by 5, you have to multiply both terms by 5. So you can show it like this, or you can show multiplying the 5 by both terms. It's completely up to yourself. Both terms get multiplied by the 5. All right? Now, I know you're saying, well, what about here? These were in brackets, right? So that's what the difference is, essentially. Okay? So when we do that, these 5s divide out. That's why we did it. Remember, like, don't get lost on why do we do that? That's why, because we want to get rid of that denominator. So we're going to clean this up for our next line. Oh. Excuse me. There we go. Sometimes these get a little bit touchy. There we go. So we'll clean this up. And we get 5 times y is 5y. And then negative 1 times 5 is negative 5. The 5's divide out, leaving you with the 3. And you have x plus 2. So I recopy this line, but what I'm going to do is multiply 3 by x and 3 by 2. So the brackets are gone, and now it's 3x plus 6. Alright? So now what you're going to do is you're going to bring everything to one side. Now, because the x is equal, the x coefficient is positive 3, we can bring everything on the right-hand side and let it equal to 0 on the right-hand, or left-hand side. It's fine. So what I'll do is I'll subtract 5y from both sides. Well, maybe I'll show that in the next line. Okay, so we'll subtract 5y and add 5, right? Because that'll eliminate these terms, give you 0, eliminate these terms, also give you 0. That's why we did it. What you do to one side, you must do to the other. So subtract 5y, and add 5. And we're going to clean this up, and we get 0 is equal to 3x minus 5y plus 11. Remember, this coefficient in front of the x must be positive. It can be 0. And if that's the case, obviously the x term would be eliminated. Okay. And there we are. And that is changing in the general form. Okay. So just check your understanding that goes along with that. Each equation in general form. So you can work on that now. The next question is graphing a line in general form. So in order to find the x-intercept, when it's in this form, or any form for that matter, but this is a nice form, it works well, we let x equal 0. Or sorry, we let y equal 0 to find the x-intercept, right? Because the x-intercept goes along here, the y value is 0. So we take our equation, and we substitute in y as 0. And then we solve for x. Okay, so we substitute that in. That'll give you 0 minus 18. Oh. And then we add the 18 to both sides. So we get 3x is equal to 18. And then we divide both sides by 3. And we get 6. Okay? So that means that the x-intercept is 6 and 0. Okay? So we go to our graph and we graph that. We'll do that in B part. Okay? And then the y-intercept. So to determine the y-intercept, we just do the opposite, obviously. We let x equal 0. So I'm going to take that back out, put y back in. Obviously. We let x equal 0. Let be gone. And plus 2y equals 18. So obviously that 0 is gone. We'll put the 18 to both sides. Get what? 2y equals 18. And we divide both sides by 2, and we get y is equal to 9. So that tells us that the y-intercept is 0 and 9, because that's when x is equal to 0. Alright? So we'll go up to our graph. We'll go 0 and 9, 0 and 6, and graph through. I'll do that with you in Desmos. So at first what we did was we found the y-intercept. The y-intercept we found, we found the x-intercept. It was 6 and 0. Point on the graph here. Next thing we'll do is we found the y-intercept, which is 0 and 9. There's 2 points. And then we will graph those. Put a straight line through the graph. So 3y plus 2y minus 18 equals 0. Oh. And there's your graph for those 2 points. Okay? So I'll copy and paste this over to our document, so you'll have it on your solution. Okay? So we'll replace that with cardinal graph. Format text through, a little technique there if you're ever using it. And there's our graph. So we have our our x-intercept at 6 and 0, our y-intercept at 0 and 9, and then we graph the line through. So there's your B part. Now verifying, that's the beauty of these. If you want to verify that's correct, all you need to do is you need to just take your equation. So just take your equation, and then what you'd want to do is you want to look at your graph and just pick a point that you can clearly see that's going through. So if I look at the graph, it clearly is going through at 2 and 6. You can see right here. Or you could pick 4 and 3. Either one will work, but you can clearly see that it's going through right here at the point right here, 2 and 6. So we'll verify using what we'll call the point T at 2, 6. We plug those in for x and y. So everywhere we see x, we substitute 2. Wherever we see y, we substitute 6. And that would give us 6 plus 12 minus 18, which would be 18 minus 18, which is indeed 0. So once both sides of the equation are equal, we know that we are correct. Okay? So just pick a point on your graph and verify it using a point. I call the point T. Okay? Go back to Desmos, and we can put a point T in there. 2, 6, see how that point came up? And we can call it T. Label it T. Alright? There we go. So there's a check your understanding that goes along with this. Very similar to what we just completed. Okay. And you can do the same thing. Alright. That's it for this video. In the next video we'll come back and we'll finish off the chapter. And we'll start with example 3. Alright, thanks everybody for watching, and we'll talk again soon.